Hello dear students, today in the lecture of integral transform, and in this video I am going to discuss you the important questions. So please watch this video. Before watching this video, I urge you to go through the definitions of the basic terms and terminologies and the formulas that you have studied throughout the year or throughout the semester, so that you can tackle my questions. And of course these are important questions, but no guarantee I am taking, and I just hope for better. And please students, I am giving you something in this crucial examination time, so in back I only expect a subscription from you, and so subscribe my channel and like, share, because I am creating these videos and giving these solutions and important questions only for you, and behind it there is no any intention or beneficial intention for me, because I am not a professional YouTuber, so okay, I am just helping in this pandemic by saving some time from my crucial and busy time schedule. Okay, so please subscribe. My views of my videos are around 100 and 100 plus, but they only view for their benefit, and don't subscribe. They don't subscribe. Please subscribe, and yes, let's start. So yes, today I am going to discuss you integral transform. Okay, so this integral transform subject or paper is very easy paper, and yes, if you have studied, then this is very easy for you, and if you have not studied the chapters and the paper, then it will be difficult for you. So definitions are very important for you, so please go through the definitions. Short answers and short questions will be designed from the definitions, and if you have studied the definitions, then I have some questions. So the first question I am giving you from the chapter of Laplace transform, and the question is Laplace transformation of t power n is gamma n plus 1 upon p raised to n plus 1 if n plus 1 is greater than 0. N plus 1 is greater than, so this you have to prove this result. Okay, and the proof is as follows. So Laplace transformation of t raised to n, from the definition of Laplace transformation I am writing this one, e power pt and t power n dt, and so put here pt equal to x, and so dt is dx 1 upon by p. This p I am writing here, p dt equals to dx. Some juniors have commented or said that the video quality is poor and sound quality is also poor, so I am just telling you that I am not a professional YouTuber, but I am just helping you through these videos, so please cooperate for the quality of video and sound, because hint is enough for you. E raised to minus x upon p raised to n dx upon p, from this substitution. Okay, and this equals to, I am telling you in voice, so just listen this. 1 upon p raised to n plus 1 integral from 0 to infinity e raised to minus x, x raised to n plus 1 minus 1 dx. Okay, and from the definition of gamma function we can write this as a gamma n plus 1 upon this p raised to n plus 1, and is a real number and is greater than minus 1. Okay, so this is actually the solution, proof. And Laplace transformation of t raised to n is n factorial upon p raised to n if n is positive integer. Okay, so this is the solution for n is real number. Okay, real number greater than minus 1. Okay, so this is the first result and its proof that I have just given you. So the second question, yes, the second question is find the Laplace transformation or transform of sine 80 upon t. So that means you have to find out the Laplace transform of sine 80 upon t. Okay, sometimes I am giving you here a note on this question. You will say that people give note in the solution or theory, but yes, I am giving the note in the question, because if you will take a equals to 1, the question will reduce to sine t upon t. Sometimes the setter are interested in setting this question instead of this question. Okay, so mind it, just take a equal to 1, you will get this result. And along with this question they ask that does the transform of cos 80 upon t exist or does not exist? Existence of the transform of cos 80 upon t is asked here. Okay, so look at the question first, and I am giving you the solution now. So Laplace transform of sine 80 upon t is nothing but the integral from 0 to infinity fx dx, which equals to integral, sorry, I am taking here s to infinity. Okay, Laplace transform of sine 80 dx, which equals to s to infinity a of a upon x square plus a square dx. You know friends, Laplace transform of sine 80 is nothing but a upon x square plus a square. So I am just using the definitions to reduce or solve the problem, and this is not a rocket science. Okay, so you know this integral, and this is obviously tan inverse x upon a, and x varies from s to infinity. Okay, so this will give you tan inverse of the upper limit, that is infinity, minus tan inverse of s upon a. Okay, so this will give you this tan inverse infinity is I think this will give you pi by 2, and this will give you tan inverse s by a. and pi by 2 minus tan inverse s by a will give you cot inverse s by a. So cot inverse s upon a is the reduction from this from here. So now let's see. So I hope the video is clear. Laplace transform of cos a t upon t. I am testing the existence for this, okay? And the answer of the sin a t upon t was cot inverse s upon a. Okay, so this will give you from definition of Laplace transformation cos a t dx, which equals to s to infinity s to infinity x upon x square plus a square. Okay, and yes, dx, which will give you half of log of x square plus a square from x s to infinity, and yes, this is half of limit x tends to infinity log of x square plus a square minus log of s square plus a square. So as you can say, this does not exist. Okay, this does not exist. It does not exist. And for limit x tends to infinity log of x square plus a square is infinite. Okay, this is infinite. This will give you infinite value. Yes, that's why this does not exist. Okay, this is adject region, and so we can say Laplace transform of, I'm just concluding the result, and my solution is cot inverse s upon a, and Laplace transformation of cos a t upon t is nothing, so does not exist. Does, d stands for does, and s stands for not, e stands for exist. Okay, I am writing this in word. Does not exist. Okay, and now after this question I am giving you one more question on the Laplace transform. Okay, and the question is to show that Laplace transform of sin a t into cos a t is equals to a times of p square minus 2a square upon p raised to 4 plus 4a raised to 4. Okay, and along with this question the setter is more interested to add one more question, because they want to make it a complete question. Okay, full question. So, and sin a t cos a t, so, and the question is friends, instead of direct sin a t, the setter is more interested in giving you sin hyperbolic a t and cos a t. Okay, so the second question is Laplace transform of sin hyperbolic a t into sin a t. So the difference between these two questions is nothing but these terms. Okay, this term. Okay, this is cos a t and this is sin a t, and this term is same in the both questions. So this will give you 2a square times p upon p raised to 4 plus 4a raised to 4, and the solution I am giving in the next page. And the solution I am giving you. So question is feeling a lengthy type feeling. Question gives a lengthy feeling, but the solution is not so lengthy as you think. Sine hyperbolic at t's Laplace transform is a upon s p square minus a square equals to f of p. We say this, and this is the assumption. Okay, and yes, I have written this from the definition of Laplace transformation of sine hyperbolic at. And now Laplace transformation of e raised to I times at of sine hyperbolic at is equals to f of p minus eta a, which will give us a upon p minus eta a square minus a square. Okay, look at picture quality, video quality is not so good because I am making this video in night time, and there is a problem of power cut. So now proceeding, this will give us a upon p square minus 2 times of a square minus 2 eta times pa, and yes, this will give us a common p square minus 2a square plus 2 eta pa upon p square minus 2a square whole square of this p square minus 2a square plus 4p square a square. Okay, so this is combination of two parts. One is real and another is imaginary part. This is a complex type number. Okay, you can say complex number. So there are two parts in this number. One part is a real part, another part is imaginary part. So just separate and equate the real and imaginary part from this LHS side. Okay, so now equating the real and imaginary parts, we get Laplace transform of cos at sine hyperbolic at. This will give you these two parts. Okay, and this is equal to, after separating the real and imaginary parts, you will get this equals to p square minus 2a square times of a upon p raised to 4 plus 4a raised to 4. Maybe video quality is not so good. I am repeating, so I am telling in loud what I am writing, I am telling also. Okay, and the Laplace transformation of sine at into sine hyperbolic at is nothing but 2a square times p upon 4a power 4 plus s p raised to 4. So on reducing, this will give you 2pi square upon p raised to 4 plus 2a raised to 4. Yeah, now the solution has completed, as you can see. So dear students, I hope after watching these videos you will subscribe the channel, and yes, I am proceeding for the next important question from the chapter of Hankel transform. Okay, Hankel transform. As I have told earlier that before going to the solution you must go through the definition, because definition of Hankel transform is important, and the setter will set the definition in short answer type question. So the first question in the Hankel transform will be to find the Hankel transform of the equation d2f upon dx square plus 1 upon x of df upon dx minus n square times f upon x square. So instead of this they may directly write in one shot that find d2f upon dx square, and this notation is for Hankel transformation. Okay, and plus 1 upon x, this is f dash. Okay, they will tell this f dash, and yes, I will write f dash notation in later, n square f upon x square. And or they may ask you directly as find Hankel transformation of f double dash plus 1 upon x f dash minus n square upon x square f. So there are three varieties or three forms of the same question, as you can see on the screen. First is d2f upon dx square plus 1 upon x df upon dx minus n square f upon x square. And second form of the question is Hankel transform of d2f upon dx square plus 1 upon x df upon dx minus n square f of x square. And the third and simplest form is to find the Hankel transformation of f double dash plus 1 upon x f dash minus n square upon x square times f. So this is nothing but f double dash stands for d2f upon dx square and f dash stands for df upon dx. So this lead to the setter for giving this question. Okay, whatever be the question, don't bother, I'm giving you the solution. Okay, so watch with patience, and mathematics means patience. d2f upon dx square equals to 0 to infinity d2f upon dx square x jn sx dx. So you must know the Bessel's function, etc., etc., and the preliminaries of Hankel transformations and the basic formulas, because to handle my questions you must know those, or just cram the solution for your examination. If you don't know what are the jn sx and this jn stands for, so just cram the solution, because you don't have so much time to go through the detail of these definitions or equations or solutions and formulas. After examination you will have enough time to think over this. df upon dx in jx jn sx 0 to infinity minus 0 to infinity integral over 0 to df upon dx jn sx plus sx times jn dash of sx dx. Okay, so friends, I don't have my phone don't have some space to record the video anymore, and yes, there is a problem of power cut as I have mentioned earlier. So I will continue this lecture and this question in the next lecture. And on the next lecture I will give you more exclusive, very important questions for your examination point of view. So before that, I hope that you will go through this video and this lecture. And yes, I am leaving here because of less space in my mobile phone to record the whole video. And so please subscribe the channel. After subscription from you, I will give you the later solution and later more important questions like Parseval's theorem, proof of the Parseval theorem and statement of the Parseval theorem, and many other things that are very important for your examination. And not only those theorems and questions or solution, I will give you some tricks to memorize in a short time, how to memorize for examination, because you will be confused of the theorems like convolution theorem, Parseval theorem. These theorems and these techniques are present in every section of the unit and every unit, so I will give you the trick. Okay, so after your subscription, if you will subscribe, then I will make the second video. And just comment if you are interested to get the more important questions on the later chapters, later units. So for the inconvenience, I am sorry and regretting for the inconvenience. Okay, so just completing this video. Thank you for watching me. Stay tuned. I hope you have a healthy life and healthy time, and with good and best wishes for your examination. Good luck. Wait for the second lecture. Thank you.